Welcome back to the familiar introduction screen here at NetBeans IDE 5.0.
All right, so in this tutorial, we're going to be doing recursive methods, and we're also going to be doing the same factorial idea. So let's make a new project, a new Java application, and let's call it Recursive Fact.
Or SIVE?
Sure.
Recursive. Is that spelled right?
Yep.
Okay. You know I'm a bad speller.
Yeah. Okay, so the first thing that we're going to do is we want to define our recursive method.
And we're going to do that below the main function method.
Uh-huh.
I got to get used to saying that.
Okay, so let's define this by saying public. It's going to be static. Going to be of type long. We'll call it factorial. And the parameter we're going to be passing is int n. Let's throw our brackets in there. All right. So if we don't want to pass a negative number, because that's just a mess.
Yes.
Okay. So if n is less than 0, we'll return -1. All right. Okay. Else, if n is equal to 0, and the equivalent is the same as C++, where it's just a double equal, then we're going to return 1. Oh, got a little typo there.
That's not how you, that's right.
Resuten. That's actually German. Kevin speaks 9 languages.
Yeah, I make up my language as I go.
It's actually Kevinish. Else, we'll return n times, and then we'll call this method factorial, and then in parentheses, n minus 1. So that way we keep decrementing as we go through this. Every time it's called. Okay, so now we'll go back to the main method. Get rid of that little comment there. And now we're just going to call factorial, and in parentheses, whatever we want the number to be. So let's do 3.
Just like before.
And a semicolon. And let's run this. So this should be running recursively.
Now, we need to actually get some output here. Right?
Oh, so yeah, so
this will be system.
So when we call it, yeah, so we're going to do a system out print line, and then we'll just encase that in some parentheses.
And sometimes it doesn't help to have the IDE do all the work for you. See, Bryan's intellect is above most people, so he looks at this and he's just like, wow, recursive function, blah, blah, blah. Recursive function, if you don't know what it is, it's a function that calls itself. Right. So what it's going to do is it's going to, in memory, create a stack, and it's going to be saving all of these values on top of each other, and then when it's done, it's going to go, boom, it's going to just and calculate it and just output.
Right, so you could almost see it as like a tree branch, sort of. So we have the number 3. I'll just kind of speak through it real fast. Okay. So we start out with the number 3. So the first time we call factorial, we call it and we pass the number 3. So it's not less than 0. It's not equal to 0. So we're going to return that times, and then we're going to run the function again. So
with the new value of 2. Right. So then you're going to have 3, and then on top of that is going to be the output
or
for
like
2.
Almost like nested inside of it. You know, it's just, it keeps digging deeper and digging deeper. So it kind of like pauses in time, and then it makes another instance of this, and then the integer is now being passed as 2. So it's not less than 0, it's not equal to 0, so we're going to return again the number 2 times factorial to 1. So when we go through it that last time, we're going to return 1. So when we come back with 1, it's going to be 1 times 2, come back to 2 times 3, and it's going to return 6 and print it on the screen. So it's kind of like those little Russian eggs with the little kids that keep popping out of the inside of the egg. But only not at all like that.
I'm going to edit that part out. All right, let's do the run it.
And we get -1. Awesome.
Yeah, which is not the desired output. Because we have this here, when it becomes a negative number, we return...
Oh, we're actually doing if n is greater than 0, which we want n is less than 0. Sorry about that. If n is a negative number, we want to return -1. So let's do a less than.
Yeah, that was my fault.
Just a simple mistake.
Apologize for that. Yeah, make that less than. I love debugging.
Hey, there we go. We got the number 6. Awesome.
We got 6. Just using a different method to do it.
Right.
Recursion. We did the exact same thing with a completely different method, and we're going to come back and we're going to add more knowledge for Java.
Yep. So should we do the Fibonacci?
Oh, hell yeah.